In this demonstration, we are going to do a few things. We're going to download an FBX file from Mixamo from one character and import this file into Blender. Next, we are going to capture the motion from the pose data in Blender and have Xarkin save this as a universal motion element. Next, we will apply this motion element to a different character in Blender and observe how the motion looks with this character. Then we will edit the motion element, making some adjustments. We will save this as a second motion element. Then we will append this modified motion to the character in Blender and observe the effect of our changes. Before showing how to capture, modify, and retarget motion, we'll take a minute to show you where we started from and where things ended. We started with a downloaded FBX file from Mixamo. The file will show a character, Alien Soldier, taking a couple of steps. We then captured this pose data in the Xarkin Universal format that allows us to modify and retarget the motion. We then worked in a motion editor where we lengthened the stride, slowed the pace a bit, and then added some head pitch and made the head nod a bit. With the slower pace, we also reduced the swing in the arms. This motion was saved as a new motion element and retargeted to a different Mixamo character, Timmy. At no point did we need to manipulate keyframes or play with surface contact. We start by downloading our FBX motion file into Blender. Once imported, we can hit play to see the two strides it contains. From the Xarkin add-on, I can select Capture Cycle to launch the Capture dialog. Please note that the Capture Single and Gesture are part of the version 2 a4b plan and aren't implemented as yet. In the Cycle dialog, Xarkin has already selected the armature and has chosen Athletic Mapping from the standard library. It has also filled the start and end keyframes to be captured. If we were importing a piece of a large motion sequence, then I could specify the start and end frames for the cycle, and Xarkin would capture those for us. First, let's specify a name for the captured motion element. We'll tick the box 2, letting Xarkin know this is a walk cycle. Click OK. Xarkin will let us know if the capture is successful. We'll next move the imported character to a different starting point. We'll then import the same character in a T-pose. We'll use this to show the accuracy of the imported motion. We'll select the frame rate to 60 and eliminate the 2 frames that Mixamo provided for the FBX file. Next, we'll append the motion which we just captured. We'll select the cloud storage for our user ID and then select the newly captured motion element. When we click OK, the details are sent to Xarkin Cloud Animation Services, and it lets us know when the resultant pose data is available for use. We then import the 63 frames to the armature. Once added, we can hit play and see that Xarkin has done a good job of capturing the motion element. Now we'll remove the 2 alien soldiers from the stage and we'll add Timmy in a T-pose. Just as before, we'll set the frame rate to 60 and eliminate the 2 keyframes that came with Timmy's T-pose. Once again, we'll append the captured cycle to Timmy. We'll request a count of 4 cycles this time. This, of course, takes longer for cloud services to generate, and it will take longer for Blender to import the generated pose data. The import is complete when we see Timmy's pose change. When we play the motion, we'll notice that the cycles all fit together. The first frame is always the next frame of the last frame in the sequence. This is also true of all the standard walks, jogs, and runs that are provided as part of a4b. Now we'll move Timmy, and then add Alien Soldier again, and append the same motion element with the same count. Playing the motion, we see similar motion, but it will look somewhat different for each character as the mapped armature and mask profiles differ for the 2 characters. Next, with the stage empty, I will launch the cycle editor. I can choose to grab pose data from Blender for editing, but in this case, I will launch the editor without selecting a particular armature and motion. The editor will open in a browser tab with a spinning cube on the stage. Blender has selected our cloud storage area and the motion element Capture Walk 1 that we saved. Clicking Load will bring this onto the stage. We'll click Play to see the walk which we imported. I can also display more cycles by clicking the up arrow at the top right of the timeline. This will now show 5 cycles. We can click the down arrow to return to 1. We can see the duration for the cycle is now 1.05 seconds. We'll grab the slider handle and increase this to 1.5 seconds. When we release the handle, the cube spins as the simulator adjusts the motion to fit this new parameter. So we've slowed down the walk by making it take longer. The distance for the cycle is 1.857 meters. We'll increase this to lengthen the stride. We'll set this to a little over 2.2 meters. Now we'll play the motion and we can see the character now takes slower, longer steps. If at any point you want to change your mind, the undo button in the upper right can take you back to the previous parameter settings. Next, we'll make some adjustments to the head movement. We'll start with the angles. Here we can rotate the head movement along the 3 axes. Roll will rotate around the green axis shown, head will pitch around the red axis, and head yaw rotates the head around the unseen blue or Z axis. We want to adjust the pitch. When we grab the slider control, we can see a sinusoidal wave appear on the timeline. This is because the head also oscillates, and we will also adjust the oscillation. The peaks in the wave show how far forward the head moves in this oscillation. We can also scrub the timeline and note how the head pitch changes from frame to frame. Selecting head oscillation, we can adjust the magnitude of the pitch movement and the phase. Now if we scrub the timeline, this will not change the magnitude. Selecting the control will display the wave once again. In this case, we are going to increase the magnitude of head pitch from 2 degrees to 14 degrees. Returning to the head angles, we can scrub along the timeline to see that the max pitch forward occurs at about 25 degrees now. Now if we play our walk, we can see the effect of our adjustments. Finally, with a slower pace, we can adjust the arm swing. We'll flatten the magnitude from 26 degrees to 16 degrees. We're going to make one final adjustment here. Let's look at the foot path. There is a separation between the feet. We'll decrease this substantially to have the character walk a more specific line. The last step is to save our work as a new motion element which we'll call Modified Walk 1. Now we'll head back to Blender and make use of this new walk. Here we have Timmy on the stage. One thing to note is when we open the Append dialog, we won't see the Modified Motion element in our list. We need to refresh our Blender session to bring this information down to Blender. Having done so, we can now select our modified walk in the Append dialog. We'll leave the cycle count at 4. Having slowed the walk down, we can now see that this means more frames of pose data, which we will import. Now we can see that we have a slower walk, a longer stride, head nodding, arms swinging less, and feet taking a more deliberate line. Finally, in this example, we captured motion. However, if we select the standard library in the Append dialog, we can see that the standard library has more elements that a4b provides. all of which can be modified to meet your specific artistic intent. Going back to the motion editor, which is still in our browser, we can select this library and select a motion element from it. In this training video, we showed how to capture, modify, and apply motion in a4b. Once again, we thank Mixamo for the use of Alien Soldier and Timmy.